Hi, my name is Putri Prakoso, and today I'm going to be talking about the internal and external anatomy of a shark. So, the shark is part of the chondrichthyes group, and it has a cartilaginous skeleton, which is actually very good for the shark because it's very light and very easily maneuverable for it. And this is a good way for them to, or because of its really lightweight skeleton and easily maneuverable skeleton, it's good for them to efficiently get their prey, run away from their predators, or just to keep moving, really. So as you can see right over here on the screen, there is a dogfish shark on its little belly. And we're going to be talking about its fins. So right over here next to its shoulders, we have the pectoral fins. And these pectoral fins are mainly used for maneuvering or steering. Same thing with the pelvic fins. They essentially have the same function. And right up top here, and my pen went away, but on the top right over here, we have the second and first dorsal fin. And these dorsal fins are just used for stabilizing the shark, okay? And right here in the back, we have the caudal fin, and the caudal fin is used to keep the shark moving. It's used for thrust. It's used to get the prey just to go as fast as it can. And it's also used so that the shark keeps moving because the shark is actually top heavy, so it will sink if it does not move. So that's one way it can die. And another way it can die is if it stops moving, it can stop breathing because water needs to constantly be moving through the gills in order for it to breathe. So, but we'll go over that later in the next slide. So, 1 second. All right, and to continue my external anatomy explanation, we have over here a little closer view of the head of the shark. Right over here, we have its eye, and the really cool thing about a shark's eye is that it has a nictitating membrane, which means that it's a piece of skin that goes over the eye whenever it attacks prey, and it's used to protect the eye because its eyes are very important when catching prey, right? And then the top side of the head, we have the ampullae, and they are little pores that detect electrical signals of things that move because, you know, every single thing that moves has to have an electrical signal in order to move any of the muscles, like what I'm doing. And the shark can detect that. And from that electrical signal, it can actually detect how far that thing that is moving is. So that's really cool. And near the ampullae, we have the spiracle. And the spiracle is actually just another way for water to get in to the gills other than the mouth, because again, these gills right over here actually constantly need water flow so that it can get oxygen for the shark to breathe, which is why they cannot stop moving. And finally, right over here, we have the lateral line. And the lateral line is just used for changes in water pressure. So if anything is moving next to them, it'll feel it. And it'll also feel how far away it is from the shark. So it's pretty cool. All right, 1 second. Okay, so to continue on, right over here, we have we have the bottom side and a little bit of a tail of the shark. And on the bottom side, like I've already circled right over here, is actually just the nose. And the thing is, the shark's nose doesn't work the way that ours do. Their shark noses work in a way where it just detects pheromones or chemicals. So that's why it can sense our blood in a way, or smell our blood. So it's pretty cool. And then over here, it's its little mouth, jaws. And right over here, we have a cut tail. And from what I've read and what I've watched on dissections is that they cut this for one, to insert things into the circulatory system because there's veins and arteries that can do that. And also, it's really good for packaging so that it takes up less space. Who knew? So that's it for the external anatomy, and we'll be continuing to the internal anatomy. Continue with the internal anatomy of a dogfish shark. As you can see right over here, there are actually really big structures here. One of them being this part, this, and this hanging off a little bit over here. That happens to be the liver. And the liver is actually three-lobed, and it covers a majority of the shark when you first dissect it. And it actually helps with the buoyancy of the shark. And also you can see over here is the stomach, and this is the spleen right over here, and this is the small intestine and the colon's right at the end over there. And based off of looking at this, you can tell that this is a male because of its claspers over here. It's actually elongated. So that's how you know it's a male. So we're looking at a male dogfish shark right now. So, okay, so we obviously have a way better view of the liver here from the dogfish shark. And as I said, it's a 1, 2, and 3-lobed liver, and it's again really big because it aids in buoyancy. As you can see over here is a little sac right here, and that's just the gallbladder, and that's just the sac that holds the bile for the stomach. We have the stomach once again right over here. The spleen is this dark structure right here, and we have the small intestine. And the thing is about the small intestine is that it has a spiral valve inside of it. And the reason for that is just to slow down digestion as well as collect nutrients or be able to give them more nutrients to the shark. Because animals that have longer or elongated stomachs tend to be able to get nutrients better that way. And also this is a great way for the sharks to conserve the food that they need because they do have to swim around 24/7 and they don't necessarily eat as much as we do. So in order to help them conserve the food and get all the energy that they need, this is very helpful for them. And over here we have just a close-up or a closer view of the stomach, and it's just this really long J-shaped structure right over here next to the spleen, like I have repeated. And this part is the cardial portion of the stomach, and this is the limbic part of the stomach. To continue on about the spleen, actually, right over here that I've always been talking about and pointing out, the spleen actually creates red blood cells for the shark. In us humans, we create red blood cells in our bone marrow, but sharks don't have a bone skeleton. They have a cartilaginous skeleton. So their spleen also acts as part of their immune system. Also, you can see that the colon is right here next to the rectal area in which everything comes out, including the waist, and if it was a female, the babies would come out of there as well. And now we have a really close-up view of the stomach, spleen, and the small intestine. And I just really want to look at the small intestine because you can see this ribbing right over here. That would be the spiral valve that's in the small intestine that I was talking about that aids in slowing down the digestion and absorption of nutrients. And again, right over here, actually, not again, because I have not mentioned this. This is part of the pancreas that just sits on top of the small intestine, but there might also be another lobe of the pancreas that's actually right under the spleen. So this pancreas is actually a lot bigger. Okay, so we can see that we have a really close-up view of the liver and the small intestine, but what we really want to look at over here is actually the rectal gland. And this rectal gland is actually very important for sharks because they live in salty environments, they live in saltwater conditions, and they need a way to get rid of that salt. So the rectal gland is actually responsible for getting rid of the salt in their system. All right, so now we're looking at the shark's respiratory system. So like I said previously, sharks need to continuously be moving or else they will die because water isn't going through their gills. So sharks will swim with their mouths open to force water to go into their mouths and then out of their gills. And then as that happens, when it goes through the gills will extract the oxygen and then it'll go through the heart. And sharks actually have two hearts, and it's right here. The heart is just right in the center next to the atriums that are actually hiding right behind the heart. But also another way that they do get water into their gills is through their spiracles. And as I said previously, this is just another alternative for them to do that, but it's not always used. Their mouths are the best way to get the gills through. It's just that when they're in deeper water, if they're just in the sand, it's a really good way to just make sure that they keep breathing and make sure water still keeps flowing in. It's just, again, another passageway. But that is it for my internal and external anatomy video. This took me, I think, at least 20 tries to do, so I hope you appreciate it. And one more video to go. Woo!